Okay, so today I want to make it a little bit more fun for you guys. So let's go through each of these questions together. So we will be coding together basically. So this will be a better review for classes, I guess, which I think is one of the most important subjects for Python programming. So I mean, you can just open any notebook for any IPython notebook. So I don't think you need exactly what I have here. So this is just to follow the instructions for me, basically. Okay? So you can start your IPython notebook or PyCharm, whatever you feel. Okay. So, for example, for this one, it says write a class with name time and define a function with name print time that prints hours, minutes, and seconds. So is it too small? Should I make it bigger? Okay. Okay. All right. So how do we do this? So everybody, you guys should also start doing, I think. It's better for you to learn. So all together, we need to define a class, which is time. So you might see this object thing if they don't inherit any other class. Sometimes you might see they inherit this object. This is, I mean, for Python 3, it really doesn't matter. You can just do this too. But to make it more compatible with Python 2, I think it's a better practice to keep the object here. But it works anyway in Python 3, so just to let you know. So, well, we didn't define what the class should do yet, so let's just say pass for this. And then the next statement says define a function, but it doesn't say method of the class. So it just says define a function. So I'm just defining a function that is that has name print time. And then let's say it takes object time and then prints let's say string time hours plus let's put this and then string time minutes plus let's add colon and then also seconds. Okay, so I defined the function. Now I want to test this. So what is the best way to test it? I'll just define time, the object time or instance time that uses the class time. And let's say I just assign the attributes outside of the class definition. So let's say time, minutes, I don't know, 9, time, seconds, sorry, let's make this hours, and minutes, the 14 dot seconds, which is, let's say, 37. And then I want to test my function that I just wrote, which is print time, and just say time. Hopefully it should work. So what you also wrote should look similar. There might be little differences, but that's okay. So I run this. Okay, worked with one shot. All right, so it was a function that we just defined, and now it asks make print time a method of the class. You know what that means, right? So basically I'm gonna have this time object again. But this time I want it to be a function, method of the class. Print time. But what should I put here now to make it a method as an input? Self, right? Right. And for the rest, I can copy it pretty much, but I need to be careful. So I should change all this time with self. And I can, this part can look the same. But instead of calling the function like what we did here, saying print time, I'm gonna say time dot print time. Okay, it still works. So a very simple thing. We just made the function a method of the class that just prints the hours, minutes, and seconds. That's it. So is it clear so far? It should be super easy. Okay, so let's continue. So define a method increment that takes a value in terms of seconds and increments the time. All right, so again, I'm gonna have a time object. And we need to define increment that should take self because it's a method of the class. And now, but it should also take a value, right? So we need to know how much you want to increment the time. Okay, so let's call this value in seconds. So let's assume it is in terms of seconds. Yeah, maybe I should call it seconds. Okay, so now we need to increment the self seconds by the seconds, right? Okay, but what if it is more than 60? Increase. Not just 0, right? Could be. Okay, so what about this? While self.seconds is greater than or equal to 60, self seconds this, but what should I increase? Minutes, right? Minutes. But what if minutes become more than 60? Do the same thing. But increase the R. Okay, so let's not worry about 24 hours now because we are not dealing with dates yet. So let's stop here. And how should we test this? Again, let's define an instance called time. This is this. And then, so we can say, okay, let's keep this print time. That we just defined. Okay, So let's say time, hours. Actually, I'm gonna do this. Minutes, time. Oh, sorry. Yes, you're right. Yeah. Seconds. Let's say 19, 30, and I can say time. Print time. And I can say time increment. Let's do something that we know. Let's make it 20 and print time again. So what the output should be? So this was the initial time. And after increment, we only incremented the seconds by 20. So this was an easy one. So let's increment with something non-trivial. So let's make it 185. So what should that be? 185 is 3 minutes, 5 seconds, right? So we should be able to see it. Okay, so this one incremented by 3 minutes and 5 seconds as we expected. Okay, pretty simple. So continue. Okay, so now define a method after of this class again. That takes another time object and return true if current time is later than the input time. So which parts do I need? Class. Let's actually just get everything we already wrote. And now we need to add another function after, which we should compare with other, right? So that other is going to be another time object. So let's say we are comparing with this. So first, what should we look at? R, right? So if other or self, actually both will work. So self R and bigger than other R. Oh, hours, thank you, yes. Return true. And so if this doesn't, if this is not satisfied, we will have, we should compare minutes, right? And other dot minutes, return true. And if we don't pass that one, look at the seconds. If nothing is satisfied, it should be returned false. Does it make sense? Okay, so let's test this. Let's say current time is an instance time, and let's say seconds let's take the values what we use, 9, 14, 30. And let's take earlier time, which is also time. For this one, let's pick something earlier. Minutes, seconds, let it be 9, 11, 30. And also let's have later time. So for this one, again, hours, minutes, seconds. For this one, let's pick 9, 14, 47. So let's say print. So I'm gonna compare current time. Current time is after earlier time. And for this, let's say current time after earlier time. And do the same thing for the later time. Current time is after later time. So current time after later time. So let's see if it works. Okay, so current time is after earlier time is true, which is good. And current time is after later time is false, because later was this one, and this is the current time, and this was the earlier time. So what we wrote here actually works. So it compares self with another object, basically. Okay? All right, let's continue. Initialize the time class so that it takes hours, minutes, and seconds and creates attributes for each and set the default values to 0. I mean, I wish we could have done this before, right? So we didn't need to type like this every time, but that's fine. So I'm gonna take all this time class that I already wrote. But since we want to use this initialization, you can just say double underscore init and tell me what the input should be. Seconds, and the default values should be 0. And let's do self hours. I can do what I've been doing because I don't want it to take too many lines. Minutes, self, seconds. And this should be hours, minutes, seconds. Right? And let's
what's the difference between the two lines that you... Oh, no, never mind. What was defining it?
Okay. So for this, let's test what we wrote. So, I mean, I don't think we need to write all of those. So we can just say time instance equals time of 9, 14, 30, and we can say time dot print time. Okay, so it works. So what we did is just we just added this initialization function that creates attributes for each of these values. Okay, so this was all about this time class. So now let's move to something else. Point, which takes x and y values, overwrite the, and also overwrite the print method so that the class prints xy when called, and the default values are 0. So this point has, so it is like two-dimensional. So it is class point. I'm going to put object here. And so, well, I assume this means initialization. So I can write like this, say self. So let's input x and y. And then I can say self x is equal to x, self y equal y. Okay, that part was easy, right, so far. Now it says overwrite the print method. So every time when you run a print, we want it to print it this way, basically. So do you remember how we were doing this? What to so if you remember overloading operators. So one way to do this is using this str. That actually tells Python that when I say print the instance of this class, give me this instead of just printing that uses the built-in function. Okay, so for this one, we don't need to input anything apart from self. And it says, oh, default values are 0. Okay, so we should also have this here. And let's say return this class. So we want it to be in this format. So now I need to convert the values to string. And also y as well. Okay, so it should work, right? Oh, not here, yes. Okay, so let's define an instance time. Oh, sorry, point. Let's take some 3, 5, and then when I say print point, okay, so I got what I wanted. See, I'm just using the print function like a built-in, but it automatically detects this special function, str with double underscore. So it prints what I actually define here. Okay? All right, so we can actually overwrite plus or summation too, like we did for print. So I'm gonna copy this again. So now the summation takes another point class and return a class whose x and y values are summation of x and y attributes of two classes. So anybody remembers the name of this function for the summation? Right. So def with double underscore. Sorry, add with double underscore. But I need to take self and also other, right? Here. another point class. And what should I return? Anybody? This? What else? Yeah, but what is the relationship between x and y? So it should return and return a class. It should return it. Right. Oh, yes, self.y plus other.y. And let's test point 1, let's say 0.35, point 2, let's say 14.7, and point 3 is P1 plus P2, and let's say print point 3. Any objections? Okay, perfect, it worked. So now it knows that addition means addition of these points, and print means this is how I want to represent. So we just overrode the built-in functions, both for print and plus, sorry, some addition.
So that only does that behavior when you're doing the plus sign with class point, like objects that are of the point class. Like what if I just did like 2 plus 2? Would that?
So without having point, you mean?
Yeah, like if I made another line, you did like P3 equals P1 plus P2. What if I said like X equal, like outside of the class?
Outside of class,
Yeah,
okay.
Like at the bottom, if I said like X equals 2 plus 2, is it gonna give it? Is it gonna?
Oh, I see. So for what about for other?
Yeah.
Okay. So am I overwriting other things too?
No.
Right. It shouldn't be a good thing, right?
Yeah.
So this is actually a nice example for polymorphism.
Yeah.
So here, because of polymorphism, based on the objects, it knows the summation should be like this, what we defined here. But for others, we know this is how it is defined. Okay? Okay. Now continue. So now let's write a method for class point that overrides the multiplication operator and returns dot product of 2 points. So I'm gonna take everything from here. So any ideas what the name of this method should be? It's not that hard to guess, right? You can just say mul, and again self other. But this time we are not going to return a class. We just want to return a scalar, right? Because it's a dot product. So it should be return. Any ideas? It's a dot product between 2 points.
Just do self.x times self.y and then add that to.
Is it? Right? So that's how you define dot product between two points or two vectors. Okay, so for this, let's check. Point 1 is 0.34, point 2, 0.57, and then let's say print P1 times P2, 43. Okay. Okay, so that was all about points. Now we are gonna start talking about these card games. So how many of you like to play card games? You guys enjoy it? Okay, good. So if I mess up, you'll fix me, okay? With the names and notation, whatever. Okay, so basically for the cards, we know that there are 52 cards in a deck, and each of which belongs to one of the 4 suits and one of 13 ranks. So the suits are spades, hearts, diamonds, and clubs in descending order in bridge. And the ranks are ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. So you can I actually had a picture here. So this is how they look like, pretty much. Okay. So if you want to define a new object to represent a playing card, it should have attributes for rank and suits, right? So it should have one of these, one of 4 of these, and one of 13 of these. But what should we use? Should we use strings or numbers? What makes sense to define a card that has both suit and rank? Number, strings? Who says numbers? Or strings? Why strings?
Just because it's jack, queen, king, ace.
Okay, but we need to compare importance of cards at some point, right? How are you gonna do that? Use numbers, right? So it is what you call encoding. Just encode each of these with a number. Okay, so we know that's maybe I should say numbers. So now let's define a class card that takes suit and rank as input and creates attributes for those, and the default values are 0. 0 for suit and rank is 2. Okay, so here before writing this, let's do the encoding a little bit. So let's say we have these spades. So it is in descending order. So then I will give clubs 0 and spades 3. Makes more sense, right? Because spades are more important in bridge. And let's say hearts encode by 2, and diamonds encode by 1, and let's have clubs encoded by 0. Okay, so and also we have so ace and all other ones. So for this we can just encode 2, 3, 4, 5 up to 10 is their numbers, but let's make ace encoded by 1 and jack encoded by 11 queen by 12 and king by 13. And all the others are same for these numbers. Okay, so let's say, let's first define a class card. I'm going to say object. And since the class takes suit and rank as an input right away, I'm going to initialize it. Self and suit and rank. And I'm going to assign self suit to suit and self rank to rank. Okay, so now I'm just assuming you are going to use this kind of encoding when you create a card.
It should be equal 0 rank equal 2, right?
Oh, right, thanks. Yes. Right. So let's test this. Card 1, card, let's say, let's define spades of 3. So spades is 3, and I'm also using 3 for 3. Okay, so it works basically. I haven't worked on print method yet, but so we are able to assign. You can also, you can also add maybe some error check cases where you can say, oh, the values should be only within these limits, all that, your call. You can improve it. So, okay, so it says override print method so that people can easily read the cards such as 6 of clubs, king of diamonds, something like that. So I'm gonna have this card class. And what's the name of the function again? Right. Self. Okay, now I need to define something, right? So it needs to know the mapping between these numbers and also the true values. Like I need to know when you give me 11, that I should know that it should be jack, right? So any ideas what we should do here? Yes, yeah, dictionary or list works too. Because remember, these are like ordered. Since it's ordered, you can just use list. Ordered like 0, 1, 2, 3. Okay, so for that, I can actually define the attributes here. Let's call it suite list. So the first one was clubs. Second one is diamonds. Hearts, right? I'm not okay. Hearts and spades. And let's have rank list. Well, for rank list, it's a little bit different because we start with 1 only. We start with 1 and go all the way to 13. So I can actually, maybe I can just copy this. But so I'm gonna start the 0th index with none because I don't need anything there, and I'm gonna make everything here a string. sorry. Okay, so I have the mapping now, and I want to now be able to print that, so something like key, so 6 of clubs, so rank should come first, right? So from rank list, or you can say self too. I think you can say both, yeah. Self rank list and self rank plus of so I want to be able to use multiple lines here. That's why I added parentheses. Self suite list okay, so rank of suite. Okay, let's see my card. Let's create a card which is let's say 3 of 8, so 3 should be spades, so it should give us spades of 3. Oh no, 8 of spades, right? Should get, print my card, and also have, okay, let's see. Okay, this works. So let's try something little bit trickier. So instead of, so change this with 1, change this with I don't know, 12. So what should that print? Queen of diamond. Okay. Okay.
But the rank list in the first is now by into 0. The output should be none of the diamond.
Oh, you mean if I have 0 here?
We need to check the rank is 0 in the string method.
Yeah, so you can add some test cases here. So we should never have this. But indexing starts with 0.
If we don't aid the check in the method, what will be print out? By
Okay.
the card 0.
So this.
So the check method is necessary.
Well, let's say, because I didn't make this string, or I can also do this, none of diamonds. So it's really a matter of design what you want to put here, but you should never have 0 here anyway. So you should probably add some test cases where you don't.
If we don't have this now, when we doing the printout, we -1 for every rank. So in the rank list, we just have 13 items.
Yes. But you know that in your deck, you only have 13. Yeah. Of course, it's a better practice to add the test cases. Okay. All right. We have the card, and now override GT and EQ that compares self and other. So what do you think this might be? What does it sound like? Greater than, right? So I'm gonna define comparison between classes by overwriting these two. Okay, so I am gonna keep copying. Okay, so equal is easy, right? Return, oh, I should also have an input other, right? Okay, so can somebody tell me what this should return? We are comparing equality. We are checking equality between two card classes.
Equal other rank and self suit equal others.
Okay, so now I wrote this. Let's check card 1, card 3, 4, card 2, card again 3, 4, print C1 equals C2 is see, so I can just compare it this way. Let's say I mess up. Let's say I made a mistake in defining my equality for these card classes. Let's say I have this. Only ranks are equal, but suits shouldn't be equal. And that will change the definition of equality. Now, your program thinks that these two identical cards are not equal to each other because I defined equality in a different way. Actually, when I was preparing this class, I made a mistake with this equality. And yeah, it was a little bit hard to debug to find that the problem was actually with the equality in the later parts of the lecture. So now let's go back. We know that this one works. And let's say this also shouldn't work. Okay. All right, so we just overwrote equality. And now let's also define greater than. Self, other. So it says that suit is more important than rank. So if self suit is greater than other suit, return true. If self rank is greater than other rank, return true, return false if nothing is satisfied. And now let's say let's define this. C1 is card 2, 3. C2 is card 2, 4. So if C1 is greater than C2, I'm going to run this C1. So I'm printing C1 by running this. Is greater than C2 Okay. Else if C1 equals C2, because I defined equality to, we can say C1 and C2 are equal or tight. Else we can say it is less. Oh, I forgot this. So 3 of hearts is less than 4 of hearts. Okay, so we just defined greater than and equality as the way we want. And we also made sure that suit actually has priority compared to rank when we compare cards. Okay, now we have a definition of a card, and now let's define a class dex that has attributes. Yeah.
C1 is 1, 5, 1.
Hmm?
You can define C1 as 1, 5, and no 1.
1, 5.
That should be C2 bigger than C1, right? The result should be C2 bigger than C1. But I'm not sure.
So okay, so the first one is suit. So in this case, C2 is greater. Okay, let's see.
Yeah, you see C1 is bigger.
Let's see. Hmm?
I think you should ask the second statement to the first one.
You mean you think this should come before?
Yeah, this
No, but suit is more important.
we need to put the second statement into the first statement, inside the first statement. Because it's more important.
So if this is not the case, then we are tight. So we check this one.
Only if the suit is same.
The problem is if the first if it's wrong, it will not return. It will go into the second if. So you need to say else if to make sure the first is wrong, then go to the second.
Right, but if this is not satisfied,
Yeah, so
we
it will
move
go into
here.
The second.
Yes.
It will also return true. It will skip the first round.
It will skip the first one if it is less than or equal to.
Yeah. One my suit is less than you. I should go to the fourth, not to go to the second if.
Yeah.
Oh, right, all right. Yes. Sorry. Yeah, it was the definition of greater. Yes, you're right. Yes.
We should check what situation we are forced. Then the final you should do better.
Okay. Hmm? Okay. Do you wanna type?
Sure.
Let me do that. Yeah, that's not sure.
Is alif. I see. Oh, this is actually for less than. Okay. Okay, sorry. All right. Yes. Thanks, guys. It's okay. So it is fine now, right? Another example you want to try? Okay. You should be a good compiler. All right. Define a class dex that has the attribute cards, and the initialization generates 52 cards. So now we are getting more realistic here. Let's take objects. So it should do all this automatically. So we can say next self. Okay, so now it has attribute cards, so it should be a list, right? So we can have this, but we need to append the values of cards here, right? So how? Any ideas how to do that? Just for loop, right? Just for loop from 0 to 3 and also 1 to 13. So can say yes, suit in range 3, 4, because we want 0, 1, 2, 3. For rank in range, but this should start from 1, go all the way to 13. So we stop at 14. And we say self cards append. So we want to append a card, right? Which will be suit and rank. Okay. So let's test this. D is deck. Can say number of cards in deck is, let's say, d dot cards, right? So basically, I just initialize the, is it dex or deck? Yeah, maybe.
It's dex.
Yeah, I think deck makes more sense. Yeah. Maybe even change this. Okay, so this should be 52, right? Okay, good. So we have a deck class, and now it says override print method to print the contents of the deck so that each card is indented one space more than the previous card. Okay, so I'm gonna copy this. So again, I'm gonna define this underscore string. Wait, I'm typing this in the wrong place. Okay, so let's say S is an empty string, and then for let's say index I in a range number of cards, so length of self cards, S plus equals, so I'm gonna do, so I want it to be indented one space more than the previous one. So any ideas here? So can I do this? Maybe it will be easier to see if I type it like this. And then I can let's do, okay, so maybe this and string self cards I let's see. So when we run this, it should run, so each card is actually, each of these is a card class, and every time we will actually have this card, but also each time we have an indent by I times. So basically I'm multiplying with whatever card I'm dealing with by the number of spaces, and then I'm also adding X, so every time I'm just passing one line. Okay, this should work. And then we say return, of course. Return S. Okay, so let's say D back print D. Okay. Okay, it works. So basically, so for the first card, I don't have any space. For the second card, I add extra space, and so on. And finally, I return all of these as one string. So all of these is actually a single string that I'm returning. Okay? All right. But here, so this is not something we want, right? This is like everything is ordered. So when we play card games, we want to shuffle it. So let's write a method, shuffle, that shuffles the cards in a deck. So we can use the random module. So let's have all this again. But I need to import. Actually, before doing that, let me play with this rand range thing a little bit. So import random, and so random dot rand range. So what does it give me? Like, let's say 1 to 8. Okay. Let's say 2 to 5. Okay. You know, so it actually gives you a random number within this range. This random dot rand range. Okay, so now let's say I have this import random here. Name of the method is shuffle. All right, so anybody has an idea how to do this? Let's say for I in range, actually let's call this number of cards is length of self.cards, okay, and we can say this n cards. So what if every time I generate some other random number which is between 0 and n cards, and I swap self cards I and self cards J. So basically I'm just swapping whatever I have at ith index with the randomly generated index J. So J cards I. Alright, so now let's see if it actually gives me something random. So D as deck, D dot shuffle, and then print D after the shuffle. Okay, so it looks random now, right? So what I did is, so first I have the number of cards, and then for each I from 0 to number of cards, I generated a random index J within this range between 0 and n cards. And then I just swapped the values of I and J. Of course, there is a possibility that I and J could be equal, but that's fine. We are randomizing enough. Okay, so is that clear, everyone? Only one person says yes. So what is confusing here? Okay. All right, so let's continue. So write a method, pop card, that removes the last card in the deck. We are gonna need this, right, when we deal the cards. So let's copy everything. So it is def pop card So what should that be? Do you remember the pop method for lists? So just a quick illustration. So if I have these lists, which is 1, 2, 3, and then if I say l.pop, it actually returns the last value here. And if I look at the L now, you see it has been popped. So it has been removed. So we can do the same thing for this. So we have these self cards as a list. So we can just say return self cards dot pop basically. Okay, I don't think we need to test this. Simple, right? Okay, so now write a method is empty which returns true if the deck contains no cards, which we will need to stop the game anyway, or to stop dealing. Okay. That is empty. And okay, so any ideas? What should I return? Self cards equals 0, right? Okay, I mean I'm not testing these two because they are very trivial. Okay, so yes. Oh, right. Thank you. Yes. See, I should have tested. Okay. All right. So we had the class for a card. We had the class for a deck. And now we need to write a class for hand for each player, which is similar to the deck, but we may need to perform more operations that don't make sense for a deck. So let's call this class hands. But since we are gonna need some of the operations from deck, it makes sense to inherit it, right? Okay, but now, I mean, it didn't tell me anything else, so I'm just gonna say pass, just to remember I need to inherit deck. Now initialize the hand class with cards and names, where name will be an input and default value is empty string. Okay. So it says I need to have this and then some initialization. Self name, where the name default value for name is this, and what does initialize with cards mean here? Sorry. Okay, so I can just have a empty hand. Self cards. Yes. And name is name. Okay. So when I first initialize, nobody has a card. So this person has an empty list, and we also know the name. Okay. Now write a method add card that adds a card to the hand. Okay. So this add card self, can just say card. Cards, append card, right? Yes. Okay. Okay, so now write a method for deck class that deals the card into hands. And it takes two arguments, hands and number of cards. Okay, this starts getting a little bit more complicated. So let's get our deck class. Okay, so the name of the method is going to be deal. Self is going to be there anyway. It takes two arguments, hands and the number of cards. So let's say I assume hands is actually a list of hands. So list of each of these hands that we defined here, and number of cards, let's call it and cards. So let's make the default value 52. Okay, so now we need to distribute the cards to the hands, right? So we have the cards, self cards. So how should we do that? What other parameter you need to know? Let's say I have the cards and we are like 4 people. I'm going to start from the 0th player, 1st player, 2nd, 3rd, and then I need to reset all that. Right, so we need the number of players, right? Which is length of hands. And what else? So every time when we pick a card, we actually pop it from the deck, right? So every time I should pop, and then whatever is returned, add it to the hand of the corresponding player. Okay, so for that I need some sort of a for loop, right? And that for loop should be what? It should be number of cards or number of players? Are you sure? So for each card I need to go iterate. I need to iterate through all the cards.
Oh, we're doing all.
But I should probably check if it is empty. So if self is empty, break. Otherwise, so every time I should have a player number too, right? So start with the player number. Initialize a player number. What should I call it? Oh no, actually don't need that. So first we need to pop it. Cards. Self cards. No, I can just say pop card. Okay, I pop the card, and let's say current player. Let's define a current player, which will be, any ideas? So what's the relationship between I and the index of the player? Should be modulus, right?
Yep.
And then for the hands of current player, add card. So now, hands of current player is going to be a class of hands. So I'm going to say add card. Okay. Should I also return self hands? Should that be self hands or just hands? Let's see what it says. It doesn't really define. So basically, we are going to have a list of hands and we will be modifying them in place. So we are not returning anything. It doesn't say to return anything. Okay, so let's see. How should we test this? No, I think we should test it after we are done with hands. So let's keep it this way. So here, all you need to know for now is hands, which is an input to the deal, is a list of hands, so list of players, and also we have the number of cards, and then we keep adding cards to the players. Basically, we keep dealing. Okay, so now back to hand. So write a method for hand that prints the hand such that hand John contains blah blah blah, or hand John is empty. So let's get the hand class back. Okay, so we are gonna define a print. So we can do this. Self. So we need to start with a string that is that says hand. It's going to be a string anyway, I assume, the name. So self name. So if so it has the do I have is init method here for the deck. Okay, so it is empty. Okay, so I have is empty method, so maybe I can just use it. If self is empty, return s plus is empty. Otherwise, we say contains. Oh, actually, maybe I can just continue here. Deck. So hand John contains all the rest of the print method, but here I want to input self here. So this deck class for printing, it takes itself and then prints everything the way we want, but here I'm calling that function, but input is self of hand. Okay, so let's test this. Define a deck and shuffle the deck. And let's define a hand. Let's say hand of John, and we also need to deal first. So John has cards. So deal, but it needs to take a list of hands. So let's say hands. Hands is a list of hand. Now we have only one hand. It doesn't make sense to play cards by yourself. But anyway, we are just testing the code. And remember, the deal function takes hands and number of cards. So I'm going to input hands, and I'm not going to input number of cards because I set it to 52. And then let's say print hands, because after the deal, hand of John is going to be modified.
The method just have one return. It should return as.
Or yeah, yes, thanks. Okay. Let's see. Okay. Contains, but maybe after this contain, I want to add this line so it doesn't start right here. Okay, maybe 52 is too much. Let's try like 10. So it works, right? So any questions here? What I did? So I have a hand class and also a deck. So hand is kind of a subset of a deck that each player has. And I start a deck class, and then I shuffle it, and then I define a hand for John, and I need to have a list of players as hands. So here, this is my all players, and then I need to deal the cards to all these players. Let's say I have 10 cards only, and when I say print hand, it should contain it in this format. Is that clear? Okay. Okay, let's see if I'm missing anything. All right. So now we have a deck, we have hand. We had the simple class card already. And now let's define a card game class that creates a deck and shuffles it automatically. So let's say class card game object. So let's say self deck is deck, and self deck dot shuffle. Right? So every time I start this card game, it automatically defines the deck and also shuffles it right away. Oh, what happened? Self is not defined. Yes. Okay. I guess we are all tired. Self. Okay. All right. So now let's take a look into this game, Ultimate Hand Game. How many of you know this? Ultimate Hand Game? Nobody else knows? Okay, I think YouTube will explain it better than me because I'm really not into cards. So let's see. Okay, I'll skip it.
Presented by GatheringTogetherGames.com. This video covers all the aspects of the marketing coordinated by the two-or-more players. The card game is played with a standard 52 card deck with one of the queens to the top, so that only 51 cards remain. The 51 cards are dealt out one at a time, and all cards are resolved. It's okay for some players who have more cards than others.
Okay, we removed that queen, and now we are looking for the pairs. So you put the pairs away, and the next player takes one card from you, and it continues. Okay, so now this player is done, and now only 3 players are playing. So player 1 is done too. And that's 1, 2. So whoever has this queen loses the game, basically. Okay? Okay, I know the sound quality was not good, but so the whole idea is we don't want to have this queen. Okay, sorry. Okay, so we remove the queen of clubs. So queen of clubs, we remove this one, which actually has a match, which is the same color as this one. So whoever has this one, whoever is left with this card loses the game. So how do you define the match? So matches are like same color. So match of this is this, match of this is that. Okay, but since we are removing this one, so then the queen of spades doesn't have a match. So whoever has that card loses. Okay? All right. So now says define ultimate hand. So we defined hands before, but now we are going to define a hand that's specifically for this game, ultimate game. So let's say class ultimate hands. Oh, actually, we should have hands, right? We should inherit hands, because this is going to be a hands anyway, but just for a different game. And write a method called remove matches and returns the number of matches. So let's define remove matches. We don't need to input anything. And remember, hands has this cards, sub cards. So let's first copy them, because we will be modifying. It's hard to iterate over a list that you are modifying. So let's say original cards and copy sub cards. And remember, this is what I need to do to make it a real copy. Otherwise, it will just point. If I do this, it will actually modify both lists. So in order to remind Python to create another copy of self cards, this is how I define. And then let's say for each card in original cards, so let's define a match for this. So if you look at this, so match is always, so the rank is supposed to be the same, but we are only looking for same color. So for clubs, for example, for the same rank, which is indexed as 0, it has to be, we need to look for suit 3, and vice versa. And for diamonds, which is 1, indexed by 1 or encoded by 1, we need to look for an index encoded by 2, and all that. So for that, do you have any idea how I should define match? Card. Any ideas? So if it is 0, I want 3. If it is 3, I want 0. If it is 1, I want 2. If it is 2, I want 1. 3 minus card dot suit. Does it make sense? But the rank should be the same. So do you guys understand this? Okay, so if match is in self cards, I'm going to remove it, right? So self cards. Oh, did you write remove function? Oh no, I think I can just say remove cards remove match. Should I also let's have a count too. So how many matches I have? And let's also print okay, I can just say hand of percentage s s matches s, and here I can just say self name, so whoever, so hand John, let's say, and this is card, this is match, and let's return count. Okay. Oh.
Match should be card star rank. Card star rank.
Match should be what?
Should be
Oh.
card suit and card star rank.
Oh, right, yeah, yes, you're right. Yes, thank you.
And the suit should
Oh, suits? No. Hmm?
I think
be just the suit.
yeah,
Suit
that's
C.
you know.
Just you
Oh. Right. Okay. How to test this? Okay, demonstrate how to start a game and remove matches. So we need to start with a deck. Actually, I want to start with setting the random seed to something. So we all get the same result. And so let's call it a game, card game. And to define a hand for this game, alt made hand, and it has we can input the name, let's say Sue. So we know that this game actually has cards, sorry, deck. It has a deck. So we can say game.deck.deal to the, so let's say I have again only one player. Again, doesn't make sense, but just to test my code, hands. And okay, so now I can say print hand. And let's say oh, we don't actually, we can print hand or just put some like some pointer for ourselves and run this method we just typed, remove matches. Okay, so what does this do? So first I just set the seed, and I have a game that that calls this class card game that automatically creates a deck for you and shuffles it, like shown here. And I define a hand for alt mate. The name of the player is Sue. And I define a list of hands which for each, where each entry is a different player. And then I say game deck deal of over all hands. So I print the hands and then I remove the matches. Okay, so you know what, so I'm gonna make this again smaller number so we can see. So okay, but it's hard to get matches with that. Okay, so this was Sue's hand, all this, and when we said remove matches, it actually finds that 5 of clubs matches 5 of spades, and it removes them. So we have only one match here. Okay, so our function remove matches actually work. Oh, this one, yes. So it just creates the deck and shuffles it right away. Yeah. Okay, so let's continue. So write a class altmate game that inherits card game and has a method that removes all the matches in all hands. So we can assume it has self.hands attribute. So let's say class. So we are defining a new game which inherits card game. And what should we call it? Let's call remove all matches self. So we want to know how many matches we have in the first round, let's say. So start with count 0. And for for each hand, so we can assume we actually have self.hands attribute. So we can say hands in self.hands. So increase the count and run remove matches for this hand and return hand. So for each hand, I compute the remove matches and add that value to my count, or return count, sorry. And finally, I return total of matches for all players. Is it clear? Okay. So write a method, find neighbor, that takes turn as an integer input and returns the index of for the neighbor index. So let's copy all this. Find. Okay, it's too low, I guess. Okay. Find neighbor. Self. So it takes turn. Okay. So what should we be careful about here? So let's say I'm player number 1. So let's assume my neighbor, I define it just the next one, 2, let's say. But what if that player doesn't have cards to give me? Then I should go to other one, right? So for that, I need to know the number of hands first, again. And number of hands is again the length of self hands. And let's say next value, I'm looking for my candidate neighbor. But I'm starting from the next one, so let's say range from 1 to n hands. But so I need to use modulus again, right? No, modulus. Like, let's say next value is 5 and there are 4 players. So your value should be 1. So the imagine this way. So we have players 0, 1, 2, 3. And if this next value is 5, you need to start from the beginning again, right? So 0, 1, 2, 3, 0, 1, 2, 3, all that. So it should be circle. Yes, exactly. Yes. So let me check. No, we call neighbor. Turn plus next value and modulus of n hands. So whatever turn is, you can imagine turn like that time, let's say it is the index of the current player, and I look for the next one and take the modulus. So here I need to check if my neighbor has a card. So if not self hands neighbor is empty, return neighbor. So once I find a neighbor that has non-empty hands, I just return the index of that neighbor. Okay. All right. So now,
I have a question about hands is the list for all hands, right? But why I need to write self.hands, because I don't think I define the hands in this class.
I'm gonna define it too. We are gonna define it, yes. So that's why it says assume the class has self-hands attributes. We are gonna define it when we say play. Okay, so now play one turn. So we are gonna write a method called play one turn that takes an argument turn that indicates whose turn it is, and the return value is the number of matches made during this turn. So let's say if play one turn, that takes self and turn. Okay, so we should, so for one turn, how does it work? So I'm the player, so my neighbor needs to pop his or her card, and I'll add that to my cards, right? And then compute number of matches for all players at that time. So first of all, if we need to check if this player already has cards, so we can say if self hands turn is empty, what we say, yeah, just return 0. Otherwise, so we need to get the neighbor first for this turn. So we can get the neighbor by calling this neighbor function for that turn. And from that neighbor, we need to pop the cards. So let's call it picked card. For self, was it cards? No, hands, sorry. Self hands, neighbor, the pop card, right? That's what we defined. Forgot the name. I think it was pop card. Yes. So we pop the card from the neighbor, and now we need to add that card to our own hands. So hands turn add card picked card. Okay, maybe we should also print something here that says whose card was picked by whom. So we can say hand self hands turn dot name picked card. Oh, no, I don't need, yeah. So whoever's turn it is, that person just picked the card that was popped from the neighbor. And we also want to return all the matches here. So we can say count this returns all the matches only from one person. Right, so because each turn we are dealing with only one person, so we can say self hands turn remove matches. Return count. I mean, I think we should also shuffle. So after removing all the matches, it's a good idea to shuffle again. Okay, guess this should work.
The neighbor should be self-defined neighbor. It's a method.
Right, yes. Right. That's fine. Okay. Anyway, we will see when we run play. Okay, now write a method that print hands for all players. This one is easy. Let's say def, what was the name? Print hands. Hands. Self. And for hand in self hands, print hands, I guess. Okay. All right, so now what we need, so we have all these utility functions we needed. So all these were actually preparing us to hit play. But for that, we need to go through all these processes. So remember, first we need to remove the queen of clubs so it doesn't have a match, and then we need to make a hand for each player where nobody has any cards initially, but then we are gonna deal the cards, not cards. And you can also say print cards have been dealt, and now you can print the hands. And remove the initial matches, print hands again, and you play this until 50 cards are matched, okay? So I'm gonna leave this as an exercise for you guys. You can combine all these functions and classes we defined here just to write the play method for this ultimate game, okay? All right, I'm gonna stop here then. And we didn't have time for quiz, so next time. All right, any questions? Okay, thank you guys.